Welcome to Corpstruction, the podcast of the Tulsa District, U.S. Army Corps of Engineers. I'm your host, Brandon Parrish. Today I'm joined by Jarrod Breuer. Jarrod is a geotechnical engineer in our engineering division here at the Tulsa District. October the 2nd is the birthday of Carl von Terzaghi, and Terzaghi was the father of soil mechanics and geotechnical engineering. He's considered by many to have made one of the greatest impacts on the career field. And Jarrod, he's a subject matter expert in the area of geotechnical engineering. He's come to talk to us about the career field and a little bit about Carl von Terzaghi. Jarrod, tell us a little bit about yourself.
Well, I've been in Tulsa District for about 5 years, but I was born and raised in Bismarck, North Dakota, went to school at North Dakota State in Fargo, North Dakota, and then started my career in the private field in southern Minnesota in 2006. And of course, I got caught up with the recession layoffs and ended up coming to the Bureau of Reclamation, very much a sister agency to the Corps of Engineers, in Grand Island, Nebraska. And from there, I went to several other offices. I was the manager for the dam safety program for the Wyoming area office for the Bureau of Reclamation, then went to the Technical Service Center for Bureau of Reclamation in Denver in their instrumentation and inspections group, but also was able to do some details there, and then made it to Sacramento District as the Dam Safety Section Chief and Program Manager, and was eventually recruited to come to this district to be a subject matter expert for geotechnical engineering.
So when you're in school and you're learning about geotechnical engineering and you're preparing to make your way in the engineering career, in engineering specialties, how does Terzaghi play into that in terms of what you're taught? Is it something your professors, are there specific areas they talk about with regard to Terzaghi?
Oh yes, and employees that I've had have had his picture framed like a saint outside of their cubicle.
Really?
With the equations outside of it. Oh yeah, he's very much worshipped by some.
Really? Yeah. I had no idea.
But what Terzaghi really did is he codified standard practices and principles, and a lot of those were foundations for the analysis of a soil.
Yeah. So a lot of, as I understand it, ideas that, or the concepts that he, like you said, codified. There are things that engineers for, I guess, centuries or maybe even millennia to some degree, they sort of understood or knew through experience based upon where they were working, but they didn't necessarily, it was like not written down. It wasn't necessarily put it into practice as far as teaching sort of in the way that Terzaghi did it, right?
Yeah, it'd be more like a guild, like your Masons Guild or your Woodworkers Guild. You would learn about it, but what he did was do testing, lecturing, analysis, and he developed methodologies for testing, inspection, and monitoring that would give you actual values for your soils that you could use rather than just a intuitive sense. I think a lot of what people did in the past, the Romans, Egyptians, the Chinese, they had an intuitive sense to this soil is a bad soil, we need to do remediation, or this is great, we're fine right here. And those values include strengths, and there's various strengths. There's strengths from compressibility, there's torsional strength, there's shear strength, and then there's permeability, there's density, and what ends up coming up most often here in Oklahoma and Texas is expansion.
Yeah, and we sort of have these expansion, I don't know if you call them, they're like foundational cartons that you sort of use when you're dealing with some of the soils here. Can you talk about that?
Yeah, void cartons or void boxes, something that I didn't see till I moved here to Oklahoma. It's very common, especially for multi-story buildings or heavier buildings, to have a deep pile foundation with grade beams And then across the floor, there's a cardboard carton placed. And that carton is where you place concrete on top of it with the reinforcement. And what it does is it allows the expansive soils below to crush that carton as well as come back and allow the carton to decompress, but not affect the structure or crack that floor.
So can you sort of talk about the Terzaghi's principle and its implications on the fields of soil mechanic and geotechnical engineering?
Yeah, so like one of the things that Terzaghi really emphasized was to look at the geology of a site and see what the whole site's saying to you in terms of what was its past and its history, and how does that lay into how you need to design your foundation system or how you need to retain water. Um, he also really emphasized, besides testing, being on site during construction and seeing what is actually going on. What type of issues is the contractor having? What type of additional tests do we need? What type of additional exploration do we need? And codifying those into standard practices. And then the other thing that was a fight for him and is a continual fight now is the benefits of long-term monitoring. Long-term monitoring. And that includes monitoring of things such as groundwater, monitoring things such as movement of a structure, uh, as well as monitoring, say, flows from a structure. Some structures, especially dams, levees, have leak. Almost all dams leak, but it's very important to monitor how much they leak and see how much it changes over time in order to determine whether your design assumptions that you used, that again were based on a lot of Terzaghi's principles, actually stood up to the test of time.
I'm going to adjust this just a little bit. Sorry. Now, how has the practice of taking core samples, because I think this goes into some of that exploration and monitoring, how has that sort of changed the way we understand soil mechanics?
Well, core samples is where you do the testing at by taking samples. It's where the geologist writes the narrative of what he sees. So a lot of what the core sampling is based on visual interpretation initially of that geologist. Are you seeing a clay? Are you seeing a sand? Are you seeing a gravel? Or are you seeing a mix of them? Then they identify parts of those samples to go test and test for various things like gradation. Gradation meaning the size of the particles that are in there. What percentage is a fine clay? What percentage is a silt? What percentage is a sand? What percentage is a gravel? And then how those structures, that then gives you an idea of those structures' strengths or weaknesses, their permeability. But also in those core sampling, you end up taking samples to do strength testing from. So basically the core sampling enables you to take all those strengths or all those tests to a depth, and sometimes that depth can be fairly deep. I'm talking 40 feet for some building foundations, and give you an idea of what you're seeing under that site, where groundwater is, where the rock, your foundation rock is, those types of things. But right now, we're seeing 3D modeling come into play somewhat, but it's not as extensive as you would think. A lot of the stuff you see now that I'm seeing for just basic building foundations looks just the same as you would have saw 40, 50, 60 years ago. You have your standard core sampling, your standard tests, you have the recommendations, and away you go.
When you take a core sample, because we don't always have the benefit of being able to say, okay, we need to put something on a site, and this is the site, and then after you do those tests, you discover this is what the makeup is, the soil makeup is, or composition, or whatever. we don't always have the ability to say, okay, we need to move it to a different site. So we have to do that, right? Remediation of
Hmm.
the soil. You have to get to an area that you can work on. What are some of the aside from like the void forms we talked about just a minute ago? What are some of the other types of methods that we use to remediate for a foundation or for a building?
So for buildings, you have a couple options. You can, if the site has relatively low amount of issues, and by that I mean not a lot of groundwater, not a lot of expansive soils, you can use a shallow strip footing foundation, and that's most common around the world. But if you end up having major issues, you have to get that foundation down to a solid bedrock or some type of solid footing. And sometimes, especially if you look at coastal areas, there is no solid bedrock. You are just putting in long piles that hopefully have enough strength along that entire length to hold up that structure through a thing called skin friction. But here in Oklahoma, typically you'll get down to bedrock at some point, and you'll set that building on columns, or if you think of it a different way, on stilts, and then you build a rigid structure on the top for your first foundation floor, and the whole structure basically floats on stilts as you build it up. Then
Is that the same as piers?
piers, yep.
Piers? Okay.
It's just a way to visualize it, because if I say piers or
People think
columns,
of boats.
yeah, you might not think that this whole building is actually being held up by these very small columns that go all the way down to bedrock.
And can you talk about bedrock, because that's a term we hear a lot. I mean, even if you're building a house, you'll hear that term bedrock. Can you sort of give me an explanation of how you would define or explain bedrock to a person?
Oh, it's argued even between engineers and geologists. But what really determines it is going to be the strength parameters of that rock, because rock comes in all different hardnesses. There's some rock, shale, or even mudstone, that is not hard at all, and you expose it to air, and it immediately becomes something that looks a lot more like soil or clay. And there's
Like
other
sandstone? Is that
sandstone too.
Yeah.
Could, yep. And there's other rock where you hit it and it's firm. You'll even break the bit of the drilling rig that's taking the testing on it. And they'll have to switch out to different bits. So that's a good question, and it is often debated during the design process as to where is that foundation rock and what should be considered foundation rock.
So how has Terzaghi and his work, how's that impacted Oklahoma's landscape in terms of construction and design?
I would say there's a couple things. One, we had the Dust Bowl in the 1930s that created a federal interest to make our massive amount of reservoirs we have in this state. There are states that have more, but when you look at a map of Oklahoma, there are a lot of dams and reservoirs, especially for the population that's here. And that was to help alleviate the Dust Bowl.
The old Soil Conservation Service
Yep.
reservoirs that you see, or they're almost more like ponds in some places. Yeah.
And ours too. Ours were made for that conservation as well, but they didn't come. Most of them didn't come with a irrigation district like you see in other states. The thing that Terzaghi's methodologies helped inform us, and we lucked out on, is that with Oklahoma and Texas, there's a lot of expansive clays, which are excellent for retaining water. So most of our dams have a massive amount of clay in them, which means they don't leak very much. They're very stable in terms of a water retaining structure, and there's not much else to do when you design and build it, but build it up from the foundation up. But what that also has done with this amount of expansive clay in Oklahoma, Texas, it has made it very difficult for rigid structures to be built. And rigid structures can be anything from roads, bridges, to your home or multi-story buildings. When people complain about how the roads are here, a lot of that is the amount of precipitation and weather we have combined with that expansive soil that creates conditions where the soil is constantly moving, expanding and heaving, and it's cracking whatever rigid structure it's against. And there are ways to remediate against that, but they're very expensive, and it's just taken time to figure out where and how those means need to be taken into account.
Where is geotechnical engineering right now compared to where it was in Terzaghi's day?
I would say in Terzaghi's day, you had engineers that had a great deal of all-round experience. They did design, construction, not so much monitoring in that day because you're building new structures, but you had engineers who had experience constructing big, massive structures and planning new massive structures. Now we're not seeing those types of things being built. We're just doing O&M on them.
And O&M is operations and maintenance.
Operations, maintenance, maybe some small modifications. But we have a lot more options for testing. It's a lot cheaper to test, and it's way cheaper to monitor structures now too. Monitoring has went from a job, especially surveying, where you had to have a 6-person survey crew to run out there and look at something, to now you can send one person with a total station, surveying equipment, or GPS. One person can do it all in a day, something that took someone weeks to do. And with LiDAR, even less. But there's a problem with that. And the problem is a lot of the wisdom that people in Terzaghi's days had has been kind of lost. And we've gotten a lot of data. Now we can collect so much data, kind of like the internet. There's a lot of stuff you can get off the internet, but there's not always a lot of wisdom that comes with it. And that's kind of the same with what we're seeing with all the data that's available in geotechnical and structural monitoring. You can get a lot of information, but if that information hasn't been processed right or collected correctly, it's just a lot of garbage in, and you can't really process that if you don't know what's going on or how it was done.
And interpretation, is that an issue as well? Is analyzing that data so that...
Yep, analyzing the data. For example, right now we're looking at some LiDAR data along our navigation system, and we're looking at these dredge pits that have been utilized by our navigation folks for 50 years, but the LiDAR data does not have any corrections for vegetation. So LiDAR will tend to hit itself off of trees and bushes and stuff like that, and that will feed itself as a surface. Well, that surface does not correspond with a ground elevation, and we're trying to figure out how much river dredging has been put into the pits. And so we're having to guesstimate some numbers, and this is more for planning purposes, to estimate how much is left in some of the dredge pits and how many dredge pits we have to yet build and how we can balance that.
And so that anybody who's listening, if you don't understand what LiDAR is, can you kind of give a brief explanation of LiDAR and how that works?
Yeah, so LiDAR is something you can collect from a plane or drone, or you can also have it on ground. That is basically a radar that points down and collects point shots of your ground or structures to create your model that you would use for design. So instead of going out and surveying an area with, well, in the old days would be a steel chain and rod running a bench level, measuring things literally by hand, you can send a drone up or plane up and have things shot with this radar equipment, LiDAR equipment, and have millions of points in seconds that would otherwise have taken an eternity to try to reproduce.
And it basically gives you like a topographical map of the landscape in terms of
Yes.
changes in the landscape, elevation changes.
Yes.
Right. So how is Tulsa updating to meet modern standards?
So Tulsa District, it kind of depends on what you mean by modern. And like I said, a lot of things I'm looking at when it comes to building construction looks very much the same way as 50 years ago. You, you probably, if you could reproduce exactly how it was produced 50 years ago, it'd be hard to tell the difference when it comes to some of the drilling reports and geotechnical reports. But for me, how we're updating in the Tulsa District is we're trying to bring things up to a more modern standard. One example is replacing some drainage pipes that are made out of corrugated metal with new PVC plastic that'll last a lot longer. Because the corrugated metal in a drainage pipe, an area where there's water protruding, it's rusting. It's rusting
Right.
away. It's reaching its design life. And we want to put something in that's going to be cost effective and last longer. And we're using that modern standard, but we're also using some updated methodologies to put material around it that meets more filter drainage criteria. And filter drainage meaning when we have a water retaining structure, we want to make sure if water's coming through that structure or underneath of it, we have a drain system that will collect just the water, not any of the soil or any rock, and smoothly transition that down to an outlet structure.
And does that chloride that, because Oklahoma tends to have pretty high chloride relative to some other areas. So does that also affect the metal, the resting, because you get a little higher salt?
Yes,
sodium
it could,
content?
especially at our chloride retention pond down there in Texas.
Yeah. So what are the typical geotechnical issues that you see in our district? Because I mean, we have structures and we have projects in half of Kansas, the Panhandle of Texas, and North Texas, and then all of Oklahoma. So, is there a difference between the different states, or they all tend to be relatively consistent?
We have a lot of expansive soil in Oklahoma and Texas, and there's a decent amount in Kansas, but it doesn't, because I don't have as much military base work up there, I don't get to see new drillings and new foundation work up there. But it was enough, they must have had enough expansive soils to make fairly tight structures. But expansive soil is really, from the geotechnical point of view, what we struggle with the most in Oklahoma.
What are some of the geotechnical issues you've seen like outside of the Tulsa District area?
So in the other states I've lived in, the issue in when they built some of these structures 50, 70 years ago was that they didn't have any expansive soil, no clay. So I've had structures that were embankment dams, well, really rock fill dams, where they built the dam out of rock, and one of them faced the dam with steel, riveted steel, and that was the water retaining component of that dam. The whole face of the dam was steel.
How do you remediate for that?
It just leaks.
Really?
And they're going through a big modification for it, but it was built in the 1930s, 1920s, and apparently they got a great deal on steel, shipped up to New Mexico, and they steel-faced it. But on others, there's several other rock-fill dams I've dealt with where they would have a very thin core of clay that's only a few feet thick, and that's just all they had to work with. There's just no material available. And in other structures, especially where there was problems, a lot of it would stem from trying to save money on the foundation excavation for the dam structure itself, and that would result in a lot of leakage around and under the structure, so much leakage that it caused major concerns, and there still aren't really fixes to some of them.
Right. How is risk a component of geotechnical engineering now?
So, what we've kind of come to in the last 50 years is we've finished construction of a lot of these facilities, but we've had a lot of experiences with failures, levee failures, dam failures. I was actually out in California when the Oroville spillway collapse happened, and I was on site within a few weeks representing the Corps, inspecting that facility. And so we're looking at our structures, and I'm not talking more of the dams and levees in terms of the quality of the structure and how it was made in the past versus what's been developed downstream from it. So a dam like Keystone has seen massive development downstream from it. There's a lot more people that live in that impact area. But a dam like Optima, that's up in the panhandle of Oklahoma, A, doesn't have any water, but B, there's really no one that lives downstream from it. And so we're trying to optimize our maintenance and modifications based on that risk structure of, and the risk is evaluating the structure itself and the population that's downstream.
And this is where we get into those grades that we give to dams when we do our dam safety inspections and everything. And
Yes.
you know, you can have a dam with relatively minor, I mean, and I would say most of them are probably relatively minor if you catch them, issues that need to be addressed. But because they have a larger population downstream, they're going to end up with a much more a much greater score, or a much
Yep.
worse score, so to speak. And
Exactly.
And it's not necessarily an indicator that the dam is in a bad way. It's an indicator of the fact that this is the higher risk that you have because you have a greater population downstream.
Exactly. Yeah, and it's the same with levees as well.
So how are you going to celebrate Terzaghi Day when we hit October 2nd?
Well, we'll see if we're coming to work or not.
You had to bring that up.
Yeah.
I'll have to cut that out. Yeah, we will. How do is there? I mean, I know that I'm sure American Society of Civil Engineers, they'll probably have a podcast episode where they do a whole Terzaghi, because I think every year they do a Terzaghi Day thing.
Well, there's a whole YouTube channel of Geo Institute Terzaghi speeches where you can listen to various lectures by the Terzaghi Institute and Geo Studios and ASCE Institute on different studies and impacts and projects they've had. So you can listen to that regularly. I listen to it, and then there's also webinars in our community of practice too for geotechnical geology and materials. It has lots of training available. Every week they have someone come on. They also have webinars available, a whole slew of training classes people can sign up for that's available.
Jarrod, thank you so much for taking the time to come down and come up here and sit down with us and talk to us about geotechnical engineering and Carl von Terzaghi. I have been trying to do a Carl von Terzaghi episode for a little over a year now, and when I first heard about him, I remember somebody brought him up in an interview I was doing, and then I kind of looked him up, and it was kind of amazing, like the impact that this person in the early 1900s to the I think he died in the 60s, right?
Yep.
The impact that he had on the field in terms of essentially like codifying all of this experience that a lot of engineers had over the years and essentially creating a field, you know. So it's always interesting to learn about figures like that, especially when they impact a field as greatly as he did. But thank you for taking the time to come up and talk to us.
You're welcome.
All right. Thank you for joining us for Corpstruction. Corpstruction is a production of the Tulsa District U.S. Army Corps of Engineers Public Affairs Office. This episode of Corpstruction is brought to you by Engineering Division, the Tulsa District. Thanks for joining us. Have a great Terzaghi Day.